This video shows how to sketch graphs by transformation. After watching the video, students will be able to sketch graphs of functions by using transformation. When sketching graphs by using transformation, there are two kinds of transformation. One is x-coordinates transformation and another one is y-coordinates transformation. When sketching graph by transformation, we must carry out x-coordinates transformation first, followed by y-coordinates transformation. Now, in x-coordinates transformation, we start from reflection in case there is a negative in front of the variable x. So we need to carry out reflection in y-axis. After the reflection, we need to see if there is a constant multiplied with the variable x, means we need to carry out enlargement by scale factor 1 over a, the constant, with y-axis as center. After the enlargement, we need to carry out translation in case there is a plus or minus b, and whether it is going to the left or to the right by b over a unit. After the x-coordinates transformation, we continue to y-coordinates transformation and we start from negative. In case there is a negative in front, means we need to carry out the reflection. Now the reflection in y-coordinates transformation, we use x-axis as the line of reflection. After the reflection, if there is a constant, multiply the function, so we need to carry out enlargement by scale factor c, the constant, with x-axis as center. After enlargement, in case there is a plus or minus d behind, so means we need to carry out translation either up or down by d unit. When sketching graph with transformation, we need to know which terms are x-coordinate transformation and which term are y-coordinate transformation. Now let's look into it. Okay, first example, the function y equals negative 2x plus 3 power 2 minus 1. So first thing, we need to identify the parent graph of the function. Since there is a power 2 here, means the parent graph is x to the power of 2. Now we simply replace the x with a brackets and compare back to the function, and we can see that 2x plus 3 is inside the brackets. So the terms that are inside the bracket, that's x-coordinate transformation. Then other terms that are outside the brackets, that's y-coordinate transformation. Next example, y equals 3x minus 1 power 3 plus 2. Same thing, we try to identify the parent graph. So we can see that the parent graph is x to the power of 3. And when we simply replace the x with a brackets, after that compare back to the function, we find that 3x minus 1 is inside the brackets. So means 3x minus 1 is x-coordinate transformation. Then the terms outside the brackets, that is plus 2 here. So plus 2 is y-coordinate transformation. Example number 3, y equals 2 over negative x plus 3. Then this function, we can see that the parent graph is 1 over x. When we simply replace x with brackets and compare back to the function, so we can see that negative x plus 3, which is inside the brackets, so means negative x plus 3 is x transformation. Then 2, since 2 is outside the bracket, so 2 is the y coordinate transformation. Example number 4, y equals 1 minus 2 over 3 minus 2x power 2. So from here we can see that the parent graph is 1 over x power 2. When we replace the x with brackets and compare back to the function, we can see that the 3 minus 2x is inside the brackets here, so means 3 minus 2x is x transformation. Then after that we can see that 1 minus 2, they are outside the bracket, so these are y coordinates transformation. Next example, y equals 1 minus 3 square root of 3 minus x. So here we know that this one, the parent graph is square root of x. So when we replace x with brackets and compare back to the function, we can see that 3 minus x is inside the brackets. So 3 minus x is the x transformation. Then the terms that are outside the brackets, that's y coordinate transformation. Example number 6, y equals negative 2 cube root of negative x minus 4, and we know that the parent graph is cube root of x. When we replace the x with brackets and compare back to the function, we know that negative x minus 4 is inside the brackets, so negative x minus 4 is x coordinates transformation. Then the rest, the number negative 2 here, because it is outside the brackets, so negative 2 is considered as y coordinates transformation. Next example, when we see the e here, so we know that the parent graph is exponential function, and after we replace the x with brackets and then compare back to the function, we can see that inside the brackets, that is negative 2x plus 1. So negative 2x plus 1 is x coordinate transformation, and the number which is outside the bracket, that is minus 3. So minus 3 is y coordinate transformation. Last, when we look at the ln, means the parent graph is lone function, and after replace x with brackets then compare back to the function, we can see that 1 minus 2x is inside the brackets, so 1 minus 2x is x coordinate transformation. Then the rest, the number 1 minus 2 here, that is outside the bracket, so this one is y coordinates transformation. Let's look at the example. Sketch the graph f of x equals 1 minus 2e to the power of 1 plus x. First, identify the parent graphs. Since there is an e here, so means the parent graph is an exponential function. So we can start the sketching from the parent graph. Next, we need to carry out the x transformation. Now from the parent graph, if we replace the x with brackets, so all the terms inside the brackets can be considered as x transformation. So in this case, the x transformation is 1 plus x. So when carry out the x transformation, first we need to see, is there a negative in front of the variable x? So now there is no negative, instead of that there is a positive here, so means there is no reflection needed. Next, we need to see, is there a constant multiply the x variable in order to carry out the enlargement. Now we can see that there is no constant here, so no enlargement needed. But now we can see that it is a plus 1 here, means we need to carry out the translation either to the left or to the right. So in order to determine this, we make it equal to 0. So means x is negative 1. If x is negative, means we need to shift the whole curve to the left hand side for 1 unit. So after shifting the whole curve to the left hand side, so the curve becomes like this. So when we compare the original curve before shifting, now we look at the critical point. Before shifting, the y intercept is 1, so when the whole curve shifts to the left hand side, the y-intercept, it is not 1 anymore. Instead of that, some other point from the right hand side when shifted to the left, so this point will intersect with the y-axis, becomes the new y-intercept. So the new y-intercept, we can calculate the value by substitute the x equal to 0 inside this formula, but not the original questions, because we haven't come to the final step. So we substitute x equal to 0 into this formula in order to find the new y-intercept. So e1 plus x then means y is equal to e, so means the value of the new y-intercept is e here. So when up to this step, we have already finished the x transformation. Now we continue to the y transformation. Same thing, we start from the reflection in case there is a negative here. So we can see there is a negative in front of the function, means we need to carry out the reflection in x-axis. So when we use x-axis to do the reflection, so the whole curve will go down. So after the reflection, the graph looks like this. So before the reflection, the curve is above the x-axis, the curve is going up. After reflection, the curve will becomes below the x-axis, and before reflection, the y-intercept is e. After reflection, the y-intercept becomes negative e. Now after the reflection, we need to see is there a constant multiply with the function. So now we can see that is a 2 multiplying with the function, means we need to carry out the enlargement by using scale factor equals to 2, because under the y transformation, scale factor is same as the constant here, and we use x as the center. So since the scale factor is equal to 2, which is greater than 1, means the position of the image is the distance from the center to the image should be greater than the object. The original curve considered as the object, so the image will be greater than the object when we calculate the distance from the center. So the position of the image is further from the original curve. So after the enlargement, the curve becomes like this. So we can look at the critical point after the enlargement. Before the enlargement, the y-axis, the y-intercept is negative e. After the enlargement, so the y-intercept becomes negative e multiplied with the scale factor, it is negative 2e. So means the new y-intercept is negative 2e. So after the enlargement, there is the translation. So now you can see that it is a positive 1. So for transformation, positive 1 is going up, negative 1 is going down. Since it is a positive 1, means we need to shift the whole curve 1 unit upwards. So after shifting 1 unit upward, the curve is like this. So we look at the critical point. Before shifting, the y-intercept is negative 2e. After shifting, because 1 unit move upwards, so the new y-intercept becomes negative 2e plus 1. Then we can see that there is a horizontal dotted line here. This horizontal dotted line, actually that is the horizontal asymptote of the exponential function. Before shifting, the horizontal asymptote is coincided with the x-axis, and means that is hidden behind the x-axis. After we shift the whole curve upwards for 1 unit, this will bring along the horizontal asymptote upwards too. So means now the horizontal asymptote, it is no more hidden behind the x-axis, and we draw it as dotted line and label with y equals 1 because shifted upward for 1 unit. Next, when the whole curve shifted upwards for 1 unit, you can see that now the curve intersect with the x-axis at one point. So this point, now we need to calculate the value. So in order to calculate the new x-intercept, we substitute y with 0 into the equation. So now e to the power of 1 plus x is equal to 1 over 2. In order to find x, we use ln. So it is ln 1 over 2. So means x, it is equal to ln 1 over 2 minus 1. So now we can label the new x-intercept as ln 1 over 2 minus 1. So finally, that is the curve. Next example. Sketch the graph fx equals 1 plus e to the power of 2x minus 1. First, we need to identify the parent graph. From the equation, we can see there is an e here. So means the parent graph is the exponential function. So means we start the graph with exponential function. Next, we need to carry out x transformation. Since the parent graph is ex, so if we replace the x with brackets, so all the terms inside the brackets, that is x transformation. So here the x transformation is 2x minus 1. So when we carry out x transformation, first we need to double check whether it is a negative here. Since there is no negative, means there is no reflection. Then we can see there is a 2 multiply x here. So this 2 means we need to carry out the enlargement by using scale factor equals 1 over 2 because this is the 2. Then the center is y-axis. So when we look at the scale factor is 1 over 2, which is less than 1. So means the image compared with the object of the curve, the image is in between the object and the center, which is somewhere here. Then when we come to 1, because 1 is at the center, so all the value at center are unchanged. Next, when we come to left hand side, same thing. Since scale factor is 1 over 2 less than 1, means the image after the enlargement is in between object and center. So means after enlargement, the graph will here. So after the enlargement, we will find that the graph is like this. Then after the enlargement, that is translation. So we can see that it is a minus 1 here, means we need to shift the graph either to the left or to the right. To determine this, we make it equal to 0. So 2x, it is 1. So x, it is equal to 1 over 2. It is positive. So means we need to shift the whole curve to the right for 1 over 2 unit. So means all the points need to be shifted to the right hand side for 1/2 unit. Now we look at the critical point 1 here. Okay, so after this value 1 initially is y-intercept. So after shifted 1/2 unit to the right, so this 1 value, it is no more y-intercept. So instead of that, other value from somewhere here when shifted to the right, so this value will intersect with y-axis, becomes the new y-intercept. So we can see after shifting, so we will get the new curve here, that is this one. So we can see now initially the value of 1 is y-intercept. When the graph shifted to the right hand side, so the 1 is no more y-intercept. Instead of that, we have the new value of y-intercept. So means we need to find the value of the new y-intercept here. So to find the y-intercept, x is equal to 0. So now we sub into the equation of this one, because this one is after the translation. Now the equation of the curve is e to the power of 2x minus 1. So the value of x we sub into this one. So y equals e to x minus 1. So means y, it is e to the power of -1. So we label the value y-intercept here. So up to here we have finished all the x transformation. Next, we need to carry out y transformation. So y transformation, when we look at the question, okay, same thing. When we carry out y transformation, also we start from reflection and double check whether there is a negative. We find that no negative here, so no reflection for y transformation, and no any constant multiplied with the e, so no enlargement for y transformation, but there is +1 here. So +1 means translation for the y transformation. So translation for the y transformation is positive going up, negative going down. So since this one is positive, so we need to shift the whole curve up for 1 unit. So means the whole curve have to be shifted 1 unit up. So now we look at the critical point here. Okay, so where initially it is e to the power of -1. When shifted 1 unit up, so it becomes like this. So means we can see that the new intercept becomes e power -1 plus 1, because we shift 1 unit up. Then another thing, you can see that there is a dotted line here. This is the horizontal asymptote of the exponential function. So before we shift the whole curve up, so before shifting, the horizontal asymptote is coincide with x-axis. So means it is hidden behind the x-axis. Okay, when we shift the whole curve 1 unit up, this will bring along the horizontal asymptote 1 unit up also. So means now the horizontal asymptote, it is no more hidden behind the x-axis, and now we need to label the horizontal asymptote by using dotted line and label with y equals 1, because we shift the whole curve 1 unit upwards. So after this, that is the curve. Next example, sketch the graph f of x equals 1 plus 2 ln x minus 1. First, identify the parent graph. Since there is Ln here, means the parent graph is lone function. So we can start the sketching from the parent graph. Next, we need to carry out X transformation. From the parent graph, when we replace the X with brackets, so all the terms inside the brackets can be considered as X transformation. So for this question, the X transformation is X minus 1. So when we carry out the X transformation, first we need to double check whether there is a negative in front of the X variable. So now we can see there is no negative in front of the X, means no reflection needed. Then we need to see whether there is a constant multiplied with the X variable. Now we can see that there is no constant, so no enlargement needed. Then we see there is a minus 1 behind the X, means we need to carry out the translation either to the left or to the right. So to determine that, we make it equal to 0. So we find that X is a positive value. If X is a positive value, means we have to shift the whole curve to the right hand side for 1 unit. So means the whole curve must be shifted to the right hand side for 1 unit. So after shifting, the new curve looks like this. Now we double check the critical point where the X intercept. Before shifting, the X-intercept is 1. After the curve shift to the right hand side for 1 unit, now the new X-intercept becomes 2. Now here we can see there is a dotted line here. This dotted line, actually that is the vertical asymptote for the lone function. Before shifting, the vertical asymptote is coincide with y-axis, means it is hidden behind the y-axis. When the whole curve is shifted to the right hand side, this will bring the vertical asymptote out from the y-axis, and so now the vertical asymptote, it is no more hidden behind the y-axis. So now we have to draw a dotted line to represent the vertical asymptote and label it as x equals 1. Now up to here we have already finished the X transformation. Next we need to carry out the Y transformation. So the Y transformation, also the same thing. First we need to see whether there is a negative here. Since there is a positive here, so means no reflection needed. Then we need to see whether there is a constant multiplied with the function. Then we see here there is 2 multiplied with the lone function, so means we need to carry out the enlargement with scale factor which is equal to 2. And for Y transformation, the enlargement, we use x-axis as the center. So in order to carry out the enlargement, so after enlargement, the new curve, because the scale factor is equal to 2 and which is greater than 1, so the new curve compared with the original curve, the distance from the center is greater than the old curve, the original curve. Then means after the enlargement, the new curve is somewhere here. Now when we come to the critical point, the x intercept, all the point on the center are unchanged, so the x-intercept is unchanged here. Then when we see the down here, same thing, since the scale factor is equal to 2, which is greater than 1, so the new curve compared with the original curve, the distance from the center, it is greater than the original curve. So the new curve will be somewhere down here. So after the enlargement, the new curve is like this. So when we can see the shape of the new curve, which is further from the center x, then the enlargement does not give effects on the vertical asymptote. Now after the enlargement, we need to carry out the translation. So since there is a positive 1 here, means the translation is going up. If there is a negative, means the translation will go down. Since there is a positive, means the curve need to translate shifted to upward for 1 unit. So after the curve shifted upwards for 1 unit, so the new curve looks like this. So we double check the critical point. Before the translation, the x-intercept is 2. After the whole curve shifted upwards for 1 unit, now 2 is not the x-intercept anymore. Beside that, some other point from down here when shift upwards, so this point will intersect with the x-axis to become the new x-intercept. So now here the new x-intercept, we need to calculate the value. So in order to calculate the new x-intercept, we substitute y equals to 0. So 1 plus 2 ln x minus 1 equal to 0. Ln x minus 1, it is equal to negative 1 over 2. So x, it is equal to exponential negative 1 over 2, because we shift the ln to the right hand side, becomes exponential. So x, it is equal to 1 plus e to the power of 1 over 2. So now we need to label the new x-intercept as 1 plus e to the power of negative 1 over 2. Then shifting upward does not give effects on the vertical asymptote. So finally, that is the curve. Now next example, sketch the graph fx equals 1 minus 3 ln 1 minus x. First, determine the parent graph. Since we can see there is ln here, means the parent graph is ln function. So we can start the sketching from ln function. Next, we need to carry out x transformation. Now from the parent graph ln x, if we replace the x with brackets, so all the terms inside the brackets can be considered as x transformation. So in this question, the x transformation is 1 minus x. So x transformation, we start from reflection because we can see it is a negative here. So reflection for x transformation, we use y axis as the line of reflection. So means the curve on the right hand side, after reflection, the curve becomes on the left hand side. The critical point 1 after reflection will becomes negative 1. So after reflection, the curve becomes like this. After the reflection, then we should be go to enlargement, but here we don't see any number multiply with x, so we don't do any enlargement. Then translation, since that is a positive 1 here, so means we need to do translation either to the left or to the right. So to determine this one, we make it equal to 0, and we find that value of x, it is equal to 1. It is positive, means we need to shift the whole curve to the right hand side for 1 unit. So the whole curve should be shifted to the right hand side for 1 unit. Now we just look at the critical point -1 here. So after shifting 1 unit to the right, so -1 will becomes 0. So means after the translation, the curve becomes like this. Okay, so now we can see there is a dotted line here. So this dotted line, actually it is the vertical asymptote of the lone function. Before shifting, now the vertical asymptote of the lone function is coincide with y-axis, and which is hidden behind the y-axis. When we shift the whole curve to the right for 1 unit, this one will bring the vertical asymptote along. So vertical asymptote will be shifted to the right hand side for 1 unit also. So means after shifting, so the vertical asymptote is no more hidden behind the y-axis. Now we need to draw a dotted line to represent the vertical asymptote, and we label it as x equals 1 because we shift the whole curve to the right hand side for 1 unit. So up to here we have already finished the x transformation. Now we go to y transformation. So y transformation, also same thing, we start from reflection because there is a negative here. So for y transformation, the reflection, we use x-axis as the line of reflection, means the curve will be reflected by using x-axis. So after reflection, the curve becomes like this. So before reflection, the curve is going down. After reflection, the curve is going up. Now as for critical point, the point which are on the x-axis are unchanged if we do reflection by using x as the line of reflection. And the reflection also doesn't give effect on the vertical asymptote. After the reflection, now we go to enlargement. Since that is a 3 multiplied with the lone, so means we need to carry out the enlargement, and by using scale factor, it is equal to 3, because under y transformation, scale factor for enlargement is same as this number. So the scale factor, it is equal to 3, and the center of the enlargement, we use x-axis as the center for y transformation. Okay, now we look at the scale factor. Since the scale factor is greater than 1, means the distance from the center to the image is greater than the distance from the center to the object. So the original curve considered as the object. Okay, because scale factor is greater than 1, so means the image will be greater than the original curve. So the curve will be something like this. Then the critical point 0. So since 0 is on the center, so this value is unchanged. Now we go to this part, same thing. Okay, the distance from center to image will be greater than object. From center to image will be greater than object. So the image will be something like this. So after the enlargement, so we can see that the graph is like that. Okay, so we can see that, so the curve will be nearer to y-axis and far away from x-axis. Okay, so the enlargement doesn't give effects on the vertical asymptote because the center is at x-axis. After the enlargement, we carry out the translation. So now since it is a positive 1 here, okay, plus 1 here, so means positive 1 for y transformation is going up, negative means going down. So means the whole curve will be shifted going up for 1 unit. Now we look at the critical point here. Initially it is 0. So when the whole curve shifted to the upward for 1 unit, so this value will change, becomes this one. So we can see the critical point. Before it is 0, after shifted 1 unit, so becomes 1. And the vertical translation will not give effects on the vertical asymptote, but the translation going up will create another new x-intercept here. Okay, so means we shift the curve up, so there is some other point will intersect with x-axis, becomes the new x-intercept. So in order to find the value x-intercept y, it is equal to 0, so we sub into the equation and make it equal to 0. Then ln is equal to 1 over 3. Now to find the x, ln shifted to right hand side becomes exponential. So means x, it is equal to 1 plus e to the power of 1 over 3. So now we label the x-intercept with 1 plus e to the power of 1 over 3 here. So finally this is the curve.